Hi everybody, today we are going to study about Newton-Raphson method. This method is generally used to improve the result obtained by one of the previous method. That means we have studied about bisection method and regular false method. Okay, in that from first and second method, it is a better method than previous ones. Okay, you will approach the roots faster by using this method. Okay, so in this, first we consider let x naught be an approximate root, of f of x is equal to 0, and let x1 is equal to x naught plus h, x1 is equal to x naught h be the correct root, to that f of x1 equal to 0, So expanding f of x naught plus h by Taylor's series, we obtain f of x naught plus h f dash of x naught plus h square upon 2 factorial f double dash of x naught plus so on equal to 0. Okay, now neglecting or you may say deleting the second and higher order derivative, we have, so deleting second and higher order, that means from these terms are deleted, that means it are considered to be 0, so it's only remain f of x naught plus h f dash of x naught is equal to 0. Therefore the value of h will be here f of x naught minus f of x naught, and this f dash will be divided, okay, when we shift toward right. Okay, which gives h is equal to minus f of x naught upon f dash x naught. As we consider here, x1 is equal to x naught plus h, therefore we can write x1 is equal to x naught and value of h is minus, so it will be minus f of x naught upon f dash of x naught. Okay, so by successive, continuing in this process by successive approximations are given as x2, x3 up to xn plus 1, x1, x2, x2, x3 up to xn plus 1, where in general you may write xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, where xn plus 1 is equal to xn minus f of xn upon f dash of xn, which is a Newton-Raphson formula, and it is used to find the roots of polynomial and transcendental equation. Okay, So here the formula is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Now we go through the examples using Newton-Raphson method. Find approximately the positive root of the equation x cube minus 3x minus 5 equal to 0. Let f of x is equal to x cube minus 3x minus 5 equal to 0. Then therefore f dash of x will be equal to derivative of this is x cube derivative is 3x square minus 3x derivative is 3. Okay, you know that formula of f or derivative of d by dx of x raised to n is n x raised to n minus 1. This is a formula. Here it is f dash x means d by dx of x raised to n. So here n for first it is x cube derivative will be, here power is 3, so n is 3 x and 3 minus 1 is 2, so it is 3x square, and d by dx of 3x is equal to x raised to 1. So constant is as it is, x raised to 1 derivative is 1 because 1 into x raised to 0 it will be 3, and derivative of constant which is minus 5 is 0. Derivative of constant is always equal to 0. Okay, constant means here it is x and it is not present in this function, it is known as constant. Now here f dash x is equal to 3x square minus 3. Now we write it as equation 1 and it as equation 2. Now f of 0 will be equal to, if you find it, it will be minus 5 because it is 0, 0 and minus 5 which is less than 0. And for f of 1 it is 1 cube minus 3. 1 cube is 1 minus 3 minus 5 which is equal to minus 3 minus 5 is minus 8 plus 1 which is minus 7. Okay, for f of 1. For f of 2 it will be equal to, f of 2 it is 3 4 is 12 minus, because 3 into 2 square is 4, 3 4s are 2, sorry, it is 2 cube is 8 minus 3 into 2 is 6 minus 5 which will be minus 6 minus 5 is minus 11 and 8 minus 11 is minus 3 which is again less than 0. And for f of 3 it will be 27 minus 3 3s are 9 minus 5 which is equal to 13. So you may write here it is less greater than 0. Okay, so therefore here f of 2 and f of 3 have opposite signs. Okay, so you can say that f of x is equal to 0 has a root in interval 2, 3. Okay, now here starting value you have to first consider value of x naught. So starting value we see that f of 2 is equal to minus 3 is nearer is nearer to 0. We have to check the nearest value at nearest value to 0. So here it is minus 3 and 13. Nearest value is minus 3. So we take f of 2 is equal to minus 3 is the nearest. Then f of 3 is equal to 13. Okay. So we consider x naught is equal to minus 3. What will be? We take starting value as a starting value. Okay. Now we know that a formula for Newton-Raphson method. Newton-Raphson formula is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Therefore, the first approximate iteration was for iteration first. The formula is x1 is equal to, because we put n is equal to 0, x1 is equal to x naught minus f of x naught upon f dash of x naught. So this is a formula for first iteration. Now here f of we have considered x naught is equal to 2 minus 3 naught. It is f of at x is equal to 2. So x naught is 2. So here f of 2, f of x naught is f of 2, which is equal to minus 3. Okay. We need to find f dash of x naught, which is equal to f dash of 2, which is equal to, now here derivative of the function is 3x square minus 3. So it will be 3 into 2 square minus 3, which is 3 into 4, 12 minus 3 is 9. Value of f dash of x naught will be equal to 9. So x1 will be equal to x naught is a 2 minus f of x naught is a minus 3 divided by 9. So it will be 2 plus 3 upon 9 value, or 3 upon 9 is 1 upon 3. So it will be calculated on calci as 2 plus 1 divided by 3, which is equal to, it is 7 upon 3, or you may write it as 2.333. 2.3333. Okay. So this is our first iteration. At first iteration we get x1 is equal to 2.3333. Okay. Now iteration 2. So it is an first required iteration. Okay. So at f of x1 we have to find f of x1, it is 0 or nearest to 0 or not, we have to check. So f of 2.3333 will be equal to, our equation is cube of x cube, which means I will take here answer cube minus 3 into x, which is our answer here, minus 5, which will be equal to 0.7037. Okay. So f of 2.333 is 0.7037. Okay. F of x1. Okay. Which is not equal to 0. Okay. Which is not a root. So you may consider next, for next iteration, we will here iteration number 2. For iteration 2, formula is x2 is equal to x1 minus f of x1 divided by f dash of x1. Okay. So here first we have to calculate of f dash of x1 is equal to, it is 3 into f dash of x1 means f dash of 2.3333. Okay, so which is 3 into x square, which is 2.3333 square minus 3. So it will be, on calculation we will calculate it, 2 into 2.3333, sorry, it is 3 into 2.3333 minus 3, which is equal to 3.9999, which is equal to 3.9999. Okay, so now x2 is equal to, here x1 is 2.3333 minus f of x1 is 0.7037 divided by f dash of x1 is 3.9999. Okay, so 0.7037 divided by 3.999 will gives us or we will calculate total answer 2.3333 minus answer. It is 2.1574. Okay, its calculation is x2 is equal to 2.1574. Okay, so $2.1574. So f of x2, we have to check f of x2. Now f of x2 will be, I will check on calci, it will be its calculation is f of 2.1574, which is equal to minus 1.4311, not equal to 0. Therefore, it is not root. So we go to next iteration, iteration 3. So it will be x3 is equal to x2 minus f of x2 divided by f dash of x2. So value of f dash x2 will be equal to, I will find it, it will be, we have to find f dash of x2 2.1574. So here it is 3 into minus 3, which is equal to 10.9631. So we will take here 2.1574 minus f of x2 is a minus of 1.4311 divided by 10.9631. So I will make all calculation on a calculator. So it will be 2.1574 minus of, so it will be minus minus will be plus, it is 1.4311. So total answer is our 2.2879, which is our x3. So here we check f of x3 will be equal to, it will be 2.2879 cube minus 3 into 2.2879 minus 5, which is equal to, I will calculate on again calci. So it will be cube 3 into answer minus 5. Its total calculation will be 0.1127. Okay. Okay, so here it is a nearer to 0. You may consider it as a nearer to 0, and after third iteration you may define x3 as a root. So at at the end of third iteration, x is equal to 2.2879 is a root of f of x equal to 0. Okay, so which is our required solution. Now consider next example. Use Newton-Raphson method to find the root of root 3, and you have to carry 3 iterations here. In solution, first we define a function, let x is equal to root 3. That means x square is equal to 3, and x square is equal to 3. We required a function f of x is equal to 0 form, so it will be equal to x square minus 3 equal to 0. Therefore we have to find root of equation x square minus 3 equal to 0. That means, or you may consider, let f of x is equal to x square minus 3. Therefore, or f dash x is equal to x square's derivative is twice x. Here 2 will be in front of x. Okay, so d by dx of x square can be written as, here n is 2, x raised to 2 minus 1, which is equal to twice x. Okay, 2 minus 1 is 1. Now in the question here also given that take x naught is equal to 1. That means initial it is given that first approximate root is given that x naught is equal to given 1. Given x naught is equal to 1. Therefore this equation number 1 will gives f of x naught is equal to, write it as equation here equation 1, and it has equation number 2. F of x naught is equal to f of 1 is equal to 1 square, which is 1 minus 3 is minus 2, which is less than 0. Consider it. And f dash of x naught also, f dash of 1 is equal to 2 into 1 is 2. Therefore in iteration 1, x formula is, Newton-Raphson formula is x1 is equal to x naught minus f of x naught divided by f dash of x naught, which will gives us x naught is 1 minus f of x naught is minus 2 divided by f dash of x naught is 2. So here it will be 2 will get cancelled. So 1 minus of minus 1 is 1 plus 1 is equal to 2. So we get x1 is equal to 2 as a first approximate root. Therefore f of x1 is equal to, here it will be 2 square minus 3, which is 4 minus 3 is 1. Okay, which is not equal to 0. Therefore iteration second is not root. x1 is not a root. For iteration 2, formula is x2 is equal to x1 minus f of x1 divided by f dash of x1. So here f dash of x1 will be, I will calculate here, for x1 is equal to 2, f dash of 2 is 1, sorry, f of 2 is 1, we have calculated here, and f dash of 2 is equal to 2 into 2, which is equal to 4. Okay, so it will be f of x1 is 2 minus x1 is 2, f of x1 value is 1 and it is 4. So 2 minus 1 upon 4, I think it is 1 upon 4. 2 minus 1 upon 4 is 1.75. 1.75. So f of 1.75, which is f of x2, is equal to, it will be equal to, function is x square minus 3 which is equal to 0.0625. I will write here 1.75 square minus 3, which is equal to 0.0625. Okay, so after second iteration you may see that it is nearer to 0, or you may calculate next iteration 3. We have given in question, we have to find up to iteration number 3. So in iteration 3 it is not equal to 0, is not root. So we go to next step. So here formula is x3 is equal to x2 minus f of x2 divided by f dash of x2. So x2 is 1.75 minus, here it value is 0.0625 divided by, now at 2 into 1.75, which is equal to 3.5. F dash of x2 is 3.5. I will you have to calculate it. F dash of x2 is equal to 2 into 1.75, which is equal to 3.5. So answer is 1.75 minus 0.0625 divided by 3.5, which will gives us 1.7321. x3 is equal to, x3 will be equal to 1.7321. Now we have to check f of x3 is equal to, it is s square minus 3, which is 0.0003189, okay, which is approximately equal to 0. You may say that. So here after third iteration x3 is equal to 1.7321 is a root of f of x is equal to 0. That means we have to find the value of root 3 is approximately equal to 1.7321. Okay, it is approximately equal to 1.7321, which is our required solution. For homework, you have to find the cube root of 7 solution by using Newton-Raphson root. Okay, you have to find cube root of 7 solution by using Newton-Raphson method. Okay, so for today we will stop here. In next lecture we will go toward our next point. Thank you.